Hello everyone, welcome back to my math tutorial video. In the previous video, I covered how to factor quadratic equations with the leading coefficient of 1. And today, I'm going to talk about factoring quadratic equations with the leading coefficient that is not equal to 1. As we all know, the general expression of quadratic equation is ax squared plus bx plus c equals 0. And today's focus is that a cannot either be 0 or 1. And then I will introduce 3 different cases of quadratic equations with a is not equal to 1. And also, I will talk about how to do the factoring in each different case. Before we move on, I would like to make some simple assumptions. So all the quadratic equations today can be factored, and those coefficients like a, b, c, they are integers. And the last one is all solutions are real number. So just make it simple for us to practice factoring, so we don't have to deal with the complex number as our solutions, or we don't have to, deal with some fractions as coefficients. So let's move on to the first case. So our case 1 is when b equals 0. And here's the general expression. So now we have ax squared plus c equals 0. And have to make sure that a and c should have different signs. So they cannot have the same signs, because if a and c, they are both positive or negative, we're going to have an x squared equals a negative number. So which is impossible, because our x is a real number. So now, how would we factor this equation? So this is the same formula in the previous video. So we have x squared minus b squared equals a plus b times a minus b. So here we can do a little bit adjustment for the two terms here. So we can say that the first term can be, let's say, square root of a times x, the whole thing squared. And the other one, I can say this is going to be like square root of absolute value of c squared. Oh, I'm sorry. So here has to be an absolute value as well. So now we can apply this formula to this equation. So now we have square root of absolute value of a, x, plus square root of absolute value of c times, here's minus, equals 0. And now the solution would be plus minus square root of absolute value of c over a. This is pretty straightforward. And let's do an example for this. And this is the expression after factoring. So what is a? So here a is 2. And our c here is negative 9. Okay, so now we can do square root of 2 times x plus square root of 9 times square root of 2x minus square root of 9 equals 0. And then we simplify it. We have square root of 2 times x plus 3 times square root of 2 times x minus 3 equals 0. And then we can solve for each parentheses, right? So our first solution would be negative 3 over square root of 2. And our second solution is going to be positive 3 over square root of 2. And we can simplify that. So we can say this is plus minus 3 times square root of 2 over 2. And here's going to be our answers. Okay, so let's move on to the second case. And the second case is when c equals 0. And general expression is going to be ax squared plus bx equals 0. It's pretty easy for us to factor this out because x is the common factor of those two terms, right? And it's already highlighted in the red color. So now we have our two solutions. One is x equals 0 and the other one is negative b over a. This is very easy. This, I will say, the easiest case among all the three cases here. And now let's do an example. And here's the general expression after factoring. And here our a is 6 and our b is negative 8, right? So then we have x, factor the x out of the two terms here. So we have x times 6x minus 8 equals 0. And now our first solution would be x equals 0. And our second solution would be 8 over 6, which is 4 over 3. Right, this is very simple. And now let's move on to the third case, and this is the most complicated one. So now both b and c are now equal to 0. So we're going to have the general expression as this: ax squared plus bx plus c equals 0. So now, let's see. Let's say if these quadratic equations can be factored, then we would always have this expression, which is the two parentheses, the multiplication of two parentheses, right? So we have an uppercase A, x plus uppercase B, uppercase C times x plus uppercase D equals 0, right? So now we're doing the same process as we did before. This is called the reverse process, right? So we kind of do like reverse. So it means that we assume we have this expression after factoring, and then we're going backwards to find the general expression. So now we have this expression, and then we expand that into this expression by using the FOIL method, right? FOIL method. And here we have AC x squared plus AD plus BC x plus BD equals 0. Now we have two expressions, right? So one is the previous one, which is ax squared plus bx plus c equals 0. And the other one is the one that we got before. It's from here. So it's AC x squared plus AD plus BC x plus BD equals 0. And they are the same thing. So they should be like equal thing, right? Okay. So what we do next is to set up an equation, right? So now we will say lowercase a is equal to the uppercase A times C, and this is small b is equal to big AD plus BC, and the C here is going to be the big B times D. They're all the coefficients, and those coefficients should be equal, right? Okay, so then we take that conclusion based on the 3 equations that we got before. We want to solve for the uppercase A, B, C, D. And how do we do it? Generally speaking, it's impossible to solve for 4 unknowns based on 3 equations, because the 3 equations cannot help us to determine the exact or the unique answer or solution for all the 4 unknowns. However, here we already made the assumption thing, right? So the coefficients, they are integers. So we may have a chance to solve for AD and BC first, right? By using factoring based on the 2 equations. The first one is AD plus BC is B. It's from the second equation on the top. And then the equation 2 is going to be AC times BD equals AC. So we do the multiplication of the first and third equation on the top. Or we say this is AD times BC equals AC. So basically we're using those 2 equations, right? And we can treat AD and BC as 2 different variable, right? Or 2 different unknown, right? So now we have 2 unknowns and we have 2 equations. So this is perfect. It's going to be easy for us to solve for AD and BC, right? Okay, so once we find the AD and BC, it's going to be easier for us to solve the case 3, right? So in other words, the strategy to solve for the case 3 is first we find A times C, which gives us AD times BC. So we have that. And the second step is try to find the 2 factors of A times C, which return the sum value of B. So it means that we have to find the 2 factors of the AC, right? And then which can satisfy our first equation, right? So by doing that, we can find our AD and our BC, right? So basically the first 2 steps is just to solve for AD and BC, since ABC, they are given. And our last step is to regroup all those terms and then factor them. So it sounds confusing, but let's do an example. So our first example is we have 3x squared plus 10x minus 8 equals 0. And here are the equations that we're going to solve. And this is the general expression for the quadratic equations in terms of those, uppercase A, B, C, D. Okay, so now what is B? So our B is going to be 10. We have AD plus BC equals 10. And AD times BC is equal to A, which is 3, times negative 8, which is negative 24. So now we just need to find the 2 factors of negative 24, which also satisfy the first equation, which is AD plus BC equals 10. So let's see. So let's say we have 1, negative 24, 2, negative 12, 3, negative 8, 4, negative 6, and 6, negative 4, and what else? 8, negative 3. and pretty much like switching the signs. So it's 12, -2, and 24, -1. So now which pair would satisfy the first equation? So I would say it's going to be 12 minus 2 equals 10, right? So now we can write the general expression as 3x squared plus 12 minus 2 times x minus 8 equals 0. And then we can distribute the coefficient of x. So now we have 3x squared plus 12x minus 2x minus 8 equals 0. Okay, so our step, so then now we can follow the third step, which is that we regroup the terms and then we factor them. So here, let's see the common factor of each coefficient. Here is 3, and for 12 I would say it's going to be 2, 2, 3, right? And then for 2 it's just 2, and for 8 it's 2, 2, 2. Okay, so now I have to group the terms that share at least one common factors, right? So I will regroup the first two, since they have 3 in common, and the last two, they have a 2 in common, right? And also I have to change the sign here since it's a negative. Okay, so then I can pull out the 3x. So it's a 3x, x plus 4. And here I can do a 2, right? So this is 2 times x plus 4. Okay, so let's see. For those two terms, we see that this parentheses is the one that they share in common. So now we can do that same thing again. So it's going to be x plus 4 times 3x minus 2 equals 0. So here we will say the first solution is when x equals -4. And our second solution is 2 over 3. So now let's do another example. So we have 5x squared minus 4x minus 12 equals 0. And here is the equations and the general expression that we can use for solving this problem. And again, so what is the b here? So b is -4, right? And a and c is 5 times -12. So now we have -60, right? So now we can find the two factors that satisfy our first equation. So we have 1, -60, 2, -30, 3, -20, 4, -15, and then 30, -2, and 60, -1. So which two can satisfy the first equation? So it's going to be 6 plus -10 equals -4. Okay, so now we get one is 6 and the other one is -10. So now we write this expression down like 5x squared plus a 6 minus 10x minus 12 equals 0. And then we distribute the coefficient of x. We have 5x squared plus 6x minus 10x minus 12 equals 0. And now let's check the common factor. So here for 5, I would say this is the only one, which is 5. 6, we have 2 and 3. 10, we have 2 and 5. And 12, we have 2 times 2 times 3. That's all the factors they have. So now we do the regrouping, right? We group the two terms that share at least one common factor. We have 5 and 10, and then the other one will be, the other group will be 6 and 12, right? So now we have 5x squared minus 10x plus 6x minus 12 equals 0, right? And then we regroup them like that. Okay, so for the first parentheses, I can pull out 5x. So now we have x minus 2 in the parentheses, and so for the second group, we can factor out 6. So now we have 6 times x minus 2 equals 0. So now we can factor out the same x minus 2. So now we have x minus 2 times 5x plus 6 equals 0. So our first solution is going to be x equals 2. And our second solution is going to be a negative 6 over 5. So now you may have a better understanding of how to solve the third case here. So follow all 3 steps and you're good to go. So let's do final example. So we have 3x squared plus 6x minus 5 equals 0. And here are those equations and expressions. Okay, so our b here is 6. And a is 3. C is negative 5. So we have a negative 15. Okay, so now let's see. We're going to find the 2 factors that can satisfy the first equation. So we have 1, negative 15, 3, negative 5, 5, negative 3, and the last one would be 15, negative 1. So which pair can satisfy the first equation? Unfortunately, none of them. Right? So there's no way. So means what? So means if we want to solve for this problem by doing factoring, we are going to have a hard time, right? So how would we solve this problem? So we are going to use quadratic formula. So that's going to be in my next video. I'm going to talk about how to use quadratic formulas to solve for those quadratic equations that cannot be easily factored. So we do have some problem that cannot be factored, right? Okay. And here's the summary. So first case, we have b equals 0, and then we take the square root of the 2 terms based on the formula that we got before. And then here's our solution, right? So x equals plus minus square root of absolute value of c over a. And our second case is when c equals 0. And then this is the easiest case that you will see on exam. Very straightforward. One is 0, the other one is negative b over a. And the third case, which is the most complicated one, you have to remember that we have to use the 3 steps, right? The first step is to find a and c, And the second step is to solve for A, D, and B, C. And after that, we regroup the terms that share at least one common factor, right? And then is just factoring. Okay, so that's pretty much for today's video. And again, in the next video, I'm going to talk about quadratic formula. And I will see you in the next video.